Okay, the next thing we're going to talk about is something special that happens if we're multiplying conjugates. So let's make sure we understand what the word conjugate means. So conjugate means if I have x plus 3, that the conjugate would be if I keep the first one the same, and then I make this opposite, so minus 3. So these are considered conjugates. If I had, let's say, 3x minus 4, the conjugate would be 3x plus 4. So these are examples of conjugates. So go ahead and take a look at number 7, and it asks, what is the conjugate of 2x minus 4? So 2x plus 4. So there is something special that happens when you're multiplying conjugates like these two here. And it only works, again, if the first term in each parenthesis is the same, and then the last two are opposites, or vice versa. So what this special property is it says just multiply the first two numbers, and then multiply the last two numbers. That's what it says. You don't have to do the whole foiling. So if we take a look at this one here, it's saying all you have to do is do this one times this one. So x times x, which we add the exponents, we get x squared, and then we multiply negative 5 times positive 5, which is negative 25. That is what this is saying that you can do as a shortcut if you're multiplying conjugates. So now, if you forget this, don't worry. You could still do it the long way, which is x times x, x times 5, and then negative 5 times x, and negative 5 times positive 5. So that this works, and it's always going to work because these two are going to end up canceling. So again, we can only apply this special property only works when you're multiplying conjugates. So if instead the problem was like this, then we cannot do x times x is x squared and 5 times 5 is 25. That would not work. It only works if they're conjugates. So this is negative 5, this is positive 5. So let's check this one out. So here we have conjugates. The first two are the same, the last two are opposites. So all we have to do is multiply 3x times 3x, which is 9x squared, and then we multiply 7 times negative 7, which is negative 49. That's what this is telling us we can do. So if we look at this example here, these two are the same, and then we have opposites, so that's how we know that we only have to multiply the first two, and then the last two. That's what that tells us there. So we would do 5x to the 4th times 5x to the 4th, which is 25x to the 8th, because we add the exponents when we multiply. And then here we have positive 6 times negative 6, which is negative 36. And that is our answer. Alright, this next example, we're just multiplying more than two polynomials together. So it's just like if we were multiplying 3 times 2 times 5. We multiply two of them together, so 3 times 2 is 6, and then we would multiply it to the third number, and we would get 30. So it's the same thing here. We multiply two of them together, and then we get that answer and multiply it to the third. Now we could do it in any order we want. Just like here, instead, I could have done 2 times 5 is 10, and then times 3, and you would still get that 30. So the order when you're multiplying, like which polynomials you're multiplying, in this case binomials, it does not matter. So in this problem here, I'm going to strategically pick to multiply these two because those are conjugates. So I can apply the rule that we just learned, which is we multiply x times x is x squared, and then -2 times +2 is -4. Okay, we got to keep the parentheses there because now that has to be multiplied to the 4x plus 7. So now we're going to multiply these binomials together. So we'd have 4x times x squared, which is 4x to the third power because we add the exponents here. And then we'd have 4x times -4, which is -16x. So now we're done with that. Now we're going to multiply the 7. So 7 times x squared is positive 7x squared. And then we have 7 times -4, which is -28. We don't have any like terms, so we're just going to put this in order. This one's the highest exponent, so we're going to put 4x cubed first. Then we'd have the positive 7x squared. And then we'd have the -16x. And then lastly, we have the -28. So if we take a look at example 12, remember we learned that we cannot distribute this, that instead we have to do 5x plus 3 times 5x plus 3 times 5x plus 3. Okay, so I'm going to go ahead and multiply these two together, so you can only do 2 at a time. So I have 5x times 5x, 5x times 3, now we have 3 times 5x, we have 3 times 3. Remember, all of that is still in parentheses because it's touching this one here that has to be multiplied. Now I'm going to go ahead and combine the like terms first. So again, all of that stays in parentheses, and then I'm going to multiply it now to the 5x plus 3. Okay, so to continue, now we're going to multiply these two together. So 25x squared times 5x is 125x to the third, because I'm going to add the exponents. And now I'm going to do 25x squared times 3, which is 75x to the second. Okay, so now I'm done with that one. Now I'm going to multiply the 30x. So 30x times 5x is 150x to the second, because again I'm adding those exponents. And now I have 30x times 3, which is positive 90x. So now we're done with the 30x. And now we multiply the 9. So 9 times 5x is 45x. And then 9 times 3 is 27. Now we're going to go ahead and combine like terms. So we have no other x cubes, so I'm going to just bring that down. Then we have a 75x squared and 150x squared. So that's going to make 225x squared. And then we have a 90x and a 45x. That's going to make 135x. And then we just have this 27 right here. So bring down the 27. And that would be our answer. Okay, so now I would like for you to pause the video and go ahead and try numbers 13 and 14. And then once you've done them, go ahead and push play and see if you did them correctly. Okay, so we reviewed in our review chapter function notation. So this is saying to take f of x, which is x squared plus 2x minus 4. And notice that I'm putting them in parentheses. The reason why I put this in parentheses is because it has to be multiplied. So I'm going to have parentheses touching like that to mean multiply. So then we have g of x. So since I'm multiplying, that's how I know I'm going to take each term in the first parenthesis in polynomial and multiply it to what's in the second parenthesis. So we have x squared times 8x squared. That's 8x to the fourth. Then we have x squared times 3. That's 3x squared. Okay, so we're done with the x squared. Now we have 2x times 8x squared. That's 16x to the third because we add the exponents. And then we have 2x times 3, which is 6x. Okay, so we're done with the 2x. Now we have one more left. We have negative 4 times 8x squared. So that's negative 32x squared. And then we have negative 4 times 3, which is negative 12. Now we're going to go ahead and combine our like terms. This one's going to go first. It has the highest exponent. Then we have the 16x to the third power next. And then we have like terms right here. So that's going to make negative 29x squared. And then we're going to bring down the 6x. And then we're going to bring down the minus 12 or the negative 12. And that would be our answer. Okay, so this one says to take f of x, so x squared plus 2x minus 4, and it says this time to subtract g of x, which is 8x squared plus 3. So in between the parentheses are not touching. So this does not mean to FOIL and multiply and stuff like that. It's asking us to subtract. So we're going to take x squared plus 2x minus 4, and then whatever's in front of the parenthesis we distribute. So we're going to distribute this minus here, which just makes all of this opposite. So we're going to have a negative 8x squared, and then we're going to have a minus 3 here. Notice the parentheses are gone. I am not multiplying. When I read this, this says to take f of x minus g of x. Nowhere does it say to multiply. So I should not be multiplying at all in this problem. So now I'm going to combine my like terms. I'm going to bring down the 2x. And then a negative 4 and a negative 3 make negative 7. And that is my answer. So again, in this problem here, we multiplied because it said to multiply. In this problem here, it says to subtract. Nowhere does it say to multiply. So I should, once I'm done distributing this minus through, the parentheses are no longer needed. I get rid of them.